Fats are lipids, also known as lipids, and as you discovered in the first chapter, carbon, hydrogen, and oxygen are the components, and it has a general triglyceride pictured right here. This is typically how we get our fat in our diet, in the triglyceride form. Glycerol is the backbone, and it has a structure that has 3 spots or 3 links, places where it can link to a fatty acid, and those chains can be different links. So it's glycerol with 3 fatty acids. And I should say fatty acid chains. The triglyceride is important for energy, and if you remember from the previous chapter, at rest we're utilizing carbohydrate and fat, but primarily fat as our energy producing fuel. As you begin to exercise, you begin to rely more on carbohydrate. And as the intensity increases, the reliance upon carbohydrate increases linearly, and fat decreases. At high intensity exercise, remember, we're relying primarily on our carbohydrate. Triglycerides or fat is a much more dense source of fuel. For each gram, it has 9 calories to offer. It's because it has very little water that's associated with it, only 0.1 gram. Carbohydrate, on the other side, has 3 grams of water with each gram of carbohydrate. So what you're looking at is a much more compact form of energy. Fat is necessary. It's necessary in our structure, in our body. It's necessary for hormone production, insulating, nervous production, nervous impulse production. Part of our brain, majority of our brain is fat, and necessary for fat-soluble vitamins. It also adds joy to eating in terms of mouthfeel, texture, and so fat is important and should be regularly consumed. The chain of the fatty acids, which will be attached to the glycerol molecule, vary in lengths. It can be short, medium, or long. The fatty acids can be saturated or unsaturated. That simply means that the long chain of carbons is fully loaded with 4 bonds. With carbon can make 4 bonds. It's equally, there are no double connections. It's saturated with hydrogen. If it's unsaturated, it means that there's 1 or more spots where the carbon is connected to its neighbor carbon twice instead of once. We know that saturated fats are solid at room temperature. Unsaturated fats are liquid. Here's a look at what that means in terms of the bonds. The omega end is the methyl end, and the methyl end is just a carbon with 3 hydrogens hanging off it. You'll see there's a hydroxyl end, which is the carbon with the OH on the end. The omega end comes into play with where that double bond is in terms of its location and its impact on how what it does in the body. The omega fatty acids are 3, 6, and 9. 3 and 6 are essential. 9 our body can manufacture based upon what's available. So the essential means that we have to consume them in our diet. The linolenic and linoleic acid, 3 and 6. We get omega-3s from our cold water fish, from walnuts, from some nuts. We get 6 from some pumpkin seed, walnuts, some oils, 6, let me jump back. 3 is more of a vasodilator, so it has a positive impact on cardiovascular health, and that's why everybody wants you to take krill oil and omega-3 fatty acids. Omega-6, we have some benefits, but there's also some potentially negative side, and that would be like inflammation and clotting and blood vessel narrowing. We don't want to omit 6s from our diet. We just need to have a balance between our 3 and 6s. So eating some cold water fish is good, some sources of omega-3s. Eicosanoids are components that can act somewhat like a hormone. Fats can be treated to become more stable and more longer shelf life. As you know, olive oil can become rancid, and if you have it for too long, so you have to pay attention to the smell and the due date. Where you can have Crisco in your cupboard and it doesn't seem to go bad for years and years and years. So the manufacturers will like to use saturated fats because they have better shelf life, and so it's cheaper. The issue with hydrogenation is it does cause some trans fatty acids, and those we know are problematic for cardiovascular disease. Let's see here. So if you look at the top picture, both of those hydrogens are on the same side of the chain. Those are cis. The trans is when the hydrogenation is on the hydrogen ion. The hydrogens are as far apart as they can get, and those are trans. Those are the results in a straighter fat, and that is the problem for cardiovascular disease and diabetes. Phospholipids are important in our diet because they form part of our cell membranes. They're involved in transportation because they're on the cell membrane and they move things in and out. So these are also really important. They keep fats soluble in water. That's the emulsification, and also for transportation. Sterols are fats that do not contain the fatty acid chain. They have the same physical properties as other fats, but they are ringed. Their structure is different, and it's important because the cholesterol is the most common sterol. It's necessary for cell membranes, nervous tissue, steroid hormones, bile acids, vitamin D. We need them. Artificial fats are a problem potentially for the digestive tract if we eat too many of them. People will eat them because they are moved through the digestive tract without having the caloric density. They're not absorbed, so you get the same sensation, mouthfeel, taste, but it doesn't have the same 9 calories per gram absorption. So they can be helpful for decreasing caloric value of a food, but you can't eat too much of it because it can cause some GI disturbance. There's no adequate intake or RDA for fat, so we just go by our recommended intake of 20 to 35% of our total calories. Majority of our fat should be in the monosaturated or polyunsaturated form, and do our best to avoid trans. You'll see on the label, you'll see the total fat, how much is saturated, and how much is trans. We look at foods throughout the whole day, our whole entire diet, of being lower saturated. Remember that saturated is something that is animal-based. Our mono and poly we tend to find more in nature. And I think that's about it. So this table 4.4 is going to have your breakdown of how we should consume fat, the type and amount for an adult. And just real quick, keep in mind about cholesterol. We used to be a lot more freaked out about consumption of cholesterol. We now know that our body, a liver production of cholesterol, there's a hereditary defect with manufacture of excessive cholesterol or causing hypercholesterolemia. That's a familial genetic trait, but our consumption of cholesterol is not as problematic as what it once was. Unless you have cardiovascular disease, there'll be some greater attention to eating less saturated fat. For athletes, we're concerned about an individual primarily that's eating too little fat. They might not be able to maintain their body weight. They might have insufficient essential fatty acids in their diet. Could be getting insufficient calories as a whole. And so fat, if an individual is fat phobic, we can't just say eat all this fat, but we do need to educate them on why fat is good and how it helps them. Too high of fat is potential for excessive weight gain, and we just don't know about high fat diet long term. But when we get to our discussions, it'll be fun to talk about that in different sports. So we have our American Heart Association, American College of Cardiologists guidelines for cardiovascular disease in terms of low fat, dairy products. Notice it doesn't say no fat. No fat typically means an addition of a substitution of simple carbohydrates, and we have to recognize that that's not helpful either. So we want to limit our saturated and trans fats primarily. And that is it for this part.